Hello, I'd like to go over my thought process for this question, remove elements. I think it's a little bit tricky because we want to remove the target in place and return the remaining elements, the count of the remaining elements. This problem tells me that it's a pointers problem. Some problems are 2 pointers, sometimes 3 pointers. Here we'll be using a 2-pointer approach. So we can look at this example. Here, we can look at it here. Sorry, this is the same input and target. So the goal is if the number equals to target, we do not want it. We don't want it. We want to remove it. So in other words, any values that does not equal to the target, we want to save it. We want to write it down. So here, I'm thinking to do one pass for I in range length of nums. So this I will advance forward regardless every step until it goes out of range. Now the important part is we have to have a writer pointer, which is initialized to 0. They're all starting here. So assume that K is my writer pointer, K and I. So let's do a dry run. So in other words, this writer pointer or K means we want to write down anything, or any number that does not equals to value. So basically any number that equals to target, we want to remove it. So in this case, we can just ignore it. Let's do a dry run. K and I are both initialized to 0. I will advance forward regardless, and K, we need to move it manually. So here is this number I is pointing to is the same as target. It is. We don't want this number, right? So we advance forward. We don't do anything. We don't write it down. We leave K where it is now. We only move K if we have to write down something. So I comes here. Now, does this number 2, where I is pointing to, equals to target? It does not. Means it's good. We want this number, right? So we will write it to where K is pointing to. 2 is here. Now K moves over because it just performed its job. I now moves again because I moves regardless, and the for loop takes care of that. Now, is this number I is pointing to the same as target? It is not. And it's good because we want to write this number. So we write this 2. Now K moves forward again. I moves forward. Is this I, the number I is pointing to, the same as target? It is. And we don't do anything. And now I goes out of scope. K stops here. And it's great because now that K is at a new available spot to write, and because it's 0 based, now that K is at index 2, and also we have exactly 2 numbers we want to keep. In this case, we don't need to do special processing to handle the 0 index, so we just return K. Okay, so let's code this up. What we do is basically just do a comparison and see if this current number at nums I equals to target. So if this current number I is looking at does not equals to this target value, what do we want? We want to write it down, right? It's something we want to keep. So it's nums at right equals to nums at I. We're overwriting that value. Whatever it exists in that current value, we're rewriting it. We want this. And now after we write it, we manually advance the right pointer. If we want to be explicit, else we just pass. This means that nums at I equals to the target value. And we don't want it, so we just ignore it. And when it ends, K will stop at the number of elements, or how many we wanted to keep. So we just return this right pointer. Space is time and space. Time, we're doing a 1 pass. Space is constant time. So we can submit it. O of n, and memory is O of 1. Thank you.